All right. So, wait till you see what happens here. Because, you know, everybody says, play the lottery, play the lottery. This is why you don't win. Okay, I'm going to show you why you don't win.
So if you play, will you win?
No. Okay, this is why we don't have those big people winning millions and billions all the time. Because it very rarely happens. So, to win the jackpot in a lottery, you must select 6 numbers. You need 6 numbers from 1 to 53. How many possible lottery combinations are there?
Too many.
Okay, so if you select the same number as many times as you want, and the order matters. So, is this multiplication rule, permutation, or combination?
Combination. Multiplication.
What makes it the multiplication rule?
You can use the number as many times as you want.
You can use the same number as many times as you want. So, you cannot use permutations, you cannot use combinations. You cannot reuse numbers with those two. So here, how many options do I have for each number?
53.
53. My numbers go from 1 to 53. So 53, 53, 53, 53, 53, 53. Or you could write this as 53 to the 6th power. Okay, they mean the same thing.
I have a question.
Yes.
On test, do you want us to put out the answer or just leave it like that? Or we can leave it like that?
I will take it like this.
Okay.
That's fine. Okay. If you cannot select the same number and you win with having the numbers in any order that you want, what is that? That is a combination. The order does not matter. It says it can be in any order. So this is a combination. What goes in front of the C?
The 53.
The 53. I've got 53 options. What goes behind the C?
6.
Why 6?
Like how many numbers?
You're picking 6 numbers. Okay. So again, it's always how many choices and then how many do I need to pick? Okay. C says if you cannot select the same number and you only win with having the numbers in the same order as what is drawn.
That's the permutation.
This is your permutations. This is your P. It has to be in the same order as drawn, so order matters. Numbers don't change though. I still have 53 to pick from, and I need to pick 6 of them. Somebody put 53P6 in their calculator. Remember how to get to your P and C screen. You have to hit math, scroll over to probability.
I don't know how to say it.
You don't,
What the hell, man?
Like 1 point.
all right, so this says
I don't know what that is.
1.65293856 e to the 10. So what this means is my number is too big for your calculator to read.
Oh.
This is scientific notation. This tells me that to get my actual number, I need to move my decimal place 10 spaces to the right. So there's 3, 4, 5, 6, 7, 8, 9, and 10. So your actual number is 16529385600. Those are your chances of winning the ultimate jackpot. 1 out of that.
Oh, yeah.
This is why we don't win the lottery.
I think there's one day it was like how this one mathematician he won the lottery like 3 different times.
Never did.
That's because we play with numbers.
I
Yeah.
I still haven't crafted them.
didn't even do it the first one.
Shoot, if I was a mathematician, I'd pay him. I'd be like, look, You can have some.
You can have some of it.
I was like, you can get 10%.
You can get 10%. Oh, aren't you sweet, sharing?
That ain't nothing. That's fucking a lot.
Okay, example 4. There are 7 possible meeting times, and a committee must meet 3 times. The number of ways to assign the meeting times is, would this be multiplication, permutation, or combination?
Multiplication. Permutation. Combination.
If you think I'm going to give it away by just listing all 3 of them, you are sadly mistaken.
Okay, I think.
Think about it. Can I reuse?
No.
No, you can't reuse meeting times. So that automatically puts you into permutation, combination. Okay? Does the order matter?
Yes. No.
Are we talking?
It's
Listen. Just listen to what I'm saying before you start shouting. Okay? Think about it. Are they talking specific slots, specific time?
Yes.
No. Where does it say 1 p.m., 2 p.m., 3 p.m.?
No.
It's just saying you must meet 3 times. It doesn't say when. It's not being specific. Therefore, that makes this combinations. What goes on front?
7.
7. What goes behind?
3.
Have you noticed a pattern that's starting to happen?
No.
Yeah.
When you write the C and the P, the bigger number always has to go on the left.
Oh, yeah.
The smaller number always goes on the
The
right.
bigger number always goes on the left and the smaller number goes on the right.
I remember that.
Good job.
Okay. The number of 5-member delegations can be created from a 9-person group. How many delegations can be selected? Multiplication, permutation, or combination?
Permutation.
It's wait, which one?
Okay. First thing you need to ask yourself, can I reuse?
No.
No, why?
Because they're people.
We're talking about people. You cannot reuse people. So multiplication rule is never going to work here. Now you need to decide, does the order matter or does it not?
No, it's a combination.
It's a combination. Again, they're not talking specifics. Look at part B. Part B says how many delegations can be selected if they're assigning them as speaker, recorder, researcher, facilitator, and administrator. That's what makes it a permutation. These specific things that they're getting, they're all getting a different job. So this one's your permutation. This one's my combination. What number goes in front? What number goes behind? 9 in front, 5 in the back. Are you starting to see the difference between C and P? Okay. You have got to be able to deduce what's the difference. What do I need?
Where did the word deduce?
Deduce?
I've never heard that word in my life.
Okay. Take a look at this one. 20 students are putting their names in a hat to be drawn to win 3 gift cards. How many different ways can students win the gift cards if they're all for $20 from Starbucks? What would I use here? Think about it and give me your why.
Because you can get all of the gifts. Wait.
I agree with combination. Tell me why.
Different ways. There's no order in how the kids win the gifts.
Not necessarily that. Take a look at the difference between A and B, and maybe you can figure it out then.
It's only from one place.
This is all from Starbucks. Everybody is getting the same exact thing. So that's what makes it a combination. Nobody is special. Nobody's getting anything different. Okay, so 20C3. When I move on to part B, now we're getting $20 gift cards, but somebody's getting a Starbucks, somebody's getting a Dunkin', and somebody's getting a Krispy Kreme. So that changes this to permutations. Okay? 12 players are on the varsity basketball team. We're asked to determine how many possible starting lineups the head coach could use. Okay? It says, how many different lineups include a point guard, a shooting guard, a small forward, a power forward, and a center? Permutation. What goes in front?
12.
What goes in the back?
5.
5. You're filling 5 positions. 3, 4, and 5. Part B says how many different lineups include any 5 players? Same thing, but it's a combination now. Because I'm not specifically giving them a spot on the field. Okay, take a look at this last one, and then we're going to start reviewing from here. How many different lineups include 2 guards, 2 forwards, and a center?
You gotta use combination and permutation.
No.
No. Never
Okay.
mind.
So, you have to do, it says, hint, this is different than question A and requires using multiple combinations. Okay, so I need to do a combination that says I'm picking 2 guards.
So combination.
So I've got 12 people to start from, and I'm picking 2 guards. Okay, it's a combination because I'm not calling them a point guard and a shooting guard. They are just guards. That's what makes it a combination, okay? It's not getting specific as to what guard. Then I'm going to pick 2 forwards. But watch what happens. I started with 12 players. I'm picking 2. So here I now have 10 players. And again, this is combination because I'm not calling them a small forward and a power forward. I'm only calling them forwards. So I'm picking 2 forwards. Now I'm down to 8. And I need 1 center, so 8C1. Look, she's back just in time.